so for the second example, we're going to do the same thing, find all of the parts. And so I'm going to start with um, simplifying this. So I noticed that out of the top, I can take out an x. So I'm going to do that first. And then after I've done that, I can see that this trinomial can be factored. So factors of 6 that add to 5 would be a 3 and a 2. So this is going to be x plus 3 times x plus 2. And then on the bottom, I see that this is a trinomial that can be factored. So factors of 2 that add to 3 would be 2 and 1. And so that would be x plus 2 and x plus 1. So I'm going to go ahead and rewrite this over here just so I can see it. So I have x times x plus 3 times x plus 2 over x plus 2 times x plus 1. And then I can see that x plus 2's are going to cancel out. So in simplest form, I have this. Okay. So since I had factors cancel out, I know that I have a whole. And so where would that become 0 would be when x is -2. So now that's my x. And then if I go to my simplified form and I plug in -2 here, I'd have -2 times the quantity. -2 plus 3 is 1. So -2 on top over -2 plus 1 is -1. So -2 over -1 would be +2. And there would be my whole. And so I'm going to go ahead and graph that. -2, +2. There's my open circle hole that my graph will not go through. Okay. I had factors that didn't cancel out. So I know I have a vertical asymptote. And that vertical asymptote would be at x equals -1. And I go back to my original and I see that the degree of the top is 1 more than the degree of the bottom. So that means there is not a horizontal asymptote. But it does mean that there will be, since it's 1 more, an oblique asymptote. Okay? And so to find that oblique asymptote, we're going to do long division, or you can do synthetic. So here's what I have here. This x squared plus 3x, we're dividing by x plus 1. Since this is a binomial, I'm going to choose to do synthetic. So remember, synthetic is that x minus r. So my r would be -1. Then I'm plugging in my coefficients, 1 and 3. And then I have 0 for my constant, right? And then we're just going to bring down. So I bring down a 1, and then 1 times -1 is -1. 3 plus -1 is 2, and then we don't care about the remainder. And so my oblique asymptote is this 1x plus 2. So there's my oblique. Excuse me. Last thing to do is find those x-intercepts. So remember, for x-intercepts, you're plugging in 0 for y into your simplified form. So it's this, and then I'm going to cross multiply. So 0, and this is a 1 on bottom, so 0 equals x times x plus 3. And I just separate and set equal to 0. So x equals 0, and then x would equal -3. So I have 2 x-intercepts, 0 and -3. So I'm going to go ahead and graph those. 0 and then -3. 1, 2, 3. Okay. Okay. So now we are going to graph our asymptotes. So I have a vertical asymptote at x equals -1. So I'm going to graph that in. And then I have an oblique asymptote at x plus 2, y equals x plus 2. So I'm going up 2 on the y-axis, and then I'm going up 1 and over 1. So my slope up 1 over 1, down 1, left 1. Okay, so you can kind of see this. Really need to be using a ruler. And if you don't have a ruler at home, use a straight edge, side of a book, note card, something like that. Okay, so if you'll notice, I still have 4 sections. Here's a section, here's a section, here's a section, and then here's a section. Here's the nice thing. I already have a point in this section, so I know a curve has to go in this section, and I actually have 2 in this section, so I know we have to go here. So when I draw my curve, I'm going to approach this asymptote here, and then I'm going to approach down here. And I crossed at that x-intercept right there. And then here, I don't go through my hole, just kind of leave it open, approach this asymptote here, cross the x-intercept, and then approach here. And there would be the graph of this reciprocal function, or sorry, rational function.